This playlist deals with some aspects of Eurocode 2 version 2023. Watch this channel for further selected topics. We will talk today about Clause 9, Serviceability Limit State, and Section 9.23, Refined Control of Cracking, and by giving some examples and conclusions. We take first an example for beams, and we will take a long-term calculation plus only bending, and we will only take into account the tension reinforcement, so AS2 is 0. We take a typical beam of 600 by 300 millimeters. The concrete quality is 30 megapascal. The stirrup diameter 10 millimeters. Concrete cover 30 millimeters. Creep coefficient 2. And we take 3 bars in the section. And the distance D1 of the center of the reinforcement to the edge or the surface of the concrete is then of course equals to 30 plus 10 is 40 plus phi of 2. Okay. We will do the calculations for a reinforcement of 3 times diameter 20, 3 times diameter 25, and 3 times 32. So we will calculate the crack width opening according to the version 2004 and according to the version 2023 for those 3 cases. And this for an increasing bending moment MSD. We can now plot the results of the different calculations into a graph. On the x-axis, it's the applied bending moment. On the y-axis, it's the calculated crack width. And we do that for the 3 diameters 20, the blue color, the 3 diameters 25, and the 3 diameters 32. The dotted line is a calculation according to Eurocode 2004, and the full lines is this according to the version 2023. Those calculations are made under the conditions that is written here. It means that the concrete compressive strength is kept smaller than 0.45 FCK because we are working in SLS. The tensile stress in the reinforcement is kept smaller than 0.8 the yield stress, and there is no crack width calculation done when the applied bending moment is smaller than the cracking bending moment. We'll notice that the dotted lines, the calculations according to the version 2004, are in all cases below the values of the version 2023. So it means that we have in the new Eurocode an increase in crack width calculations for beams. Increase is not that big, but there is an increase. You can rearrange the data, and on the y-axis now we will have the ratio of the value of 2023 divided by the one of 2004. Gives you more idea how big is this increase. And then you will see that for the different reinforcements, 3 diameters 20 or 3 diameters 25 or 3 diameters 32, you will have an increase of 9, 6, and 3%. So this 9% is mean factor, but you will see everything is above 1. So there's always an increase, but depending on the amount of reinforcement and in the diameter, you will have a range of 3 to 9% more crack width opening. We will take now an example of a slab to see if there is any difference. It is a long-term calculation with only bending and there is only tension reinforcement. The slab total depth is 250 millimeters, FCK is 30 megapascal. We will take the layer of reinforcement closest to the surface, and it's the first layer. So C is 30, or the distance D1 is of course 30 plus the V over 2. We take 10 rebars, and we will do the calculations for 10 bars diameter 8, 10, 12, 14, and 16. And then we will calculate the crack width opening for different applied bending moments. X-axis, again, the bending moment, applied bending moment. Y-axis is the calculated crack width. These are the conditions we've seen in the previous slides. These are the conditions on the concrete compressive stress, the steel tensile stress, and the bending moment, the applied bending moment. The dotted line is according to version 2004, the full lines according to versions 2023. And again, we will see here in the most cases that the new that the code 2020 in 2023 leads to a bigger calculated crack width. You will see here a point where the slope changes of the curves. Those points are in fact due that delta epsilon has a lower limit, and it must always be bigger than 1 minus kt times sigma s over es. And this point is the point where this is changing. So on the left-hand side, this is governing, and on the right-hand side, it's the other part of the formula which is governing. Another element is that you see that for a diameter 8, 10 diameters 8, you have the opposite, but this is most likely due to some instability or rounding off effects. In fact, when calculating with 10 diameters 8, you struggle to fulfill all those restrictions which are on the left-hand side. So we should ignore this portion of the graph. You can rearrange the data. On the x-axis, the bending moment. On the y-axis, the calculated crack width opening according 2023 divided by the one for 2004. Again, we will see that we have two different slopes on each curve, and this is due to, again, the under limit for delta epsilon. We will ignore the values for diameter 8. And again, you will now see the percentage of increase in crack width opening. And we can have a summary for beams 600 times 300 and for slabs 250 times 100. A summary of the examples calculated, of course. We cannot say this is general this is valid general, but most likely it will be. And you will see for beams in different reinforcement ratio and diameters of rebars, we will have an increase. Let's put it safely. You can put it an increase of 10%. The same happens with the slabs. You have more or less as a mean factor, mean increase in calculated crack width of 9 or 10%. So the conclusion is that more or less you will have an increase of 10% in the crack width according to the Eurocode 2 version 2023. Now we can ask ourselves why. Why is there now an increase of 10%? What's wrong? How does that come? We have seen that in Eurocode 2004, the crack width for members in tension was over conservative. Data showed that this was not really economical. Also, the increase in crack width in bending members due due to curvature. Because of the curvature, your crack width is larger than calculated. And this is getting more important when large diameters are involved. And the formulas gives us a higher reliability if you compare it with data out of tests. So those three elements are the main elements why we have an increased crack width, calculated crack width opening.